Hi Bobcats, this is Miss Lee, and today's video lesson is on the distributive property. Make sure as you're watching the video that you're taking good notes. Okay, we take a look here in this picture. Sally is distributing 5 cookies to each of her friends. So based on this situation, what do you believe the term distribute means? It means to share. It means to give, right? She's given each person 5 cookies. She's sharing 5 cookies with each friend. Okay, distribute means to give out or to share. So let's go through and we're going to work with algebra tiles. We're going to distribute using algebra tiles to begin with. So our expression says that 3 groups of 2 X tiles and 1 unit tile. So first we need to model that. Remember the X tile, it can be a vertical rectangle tile or it can be horizontal, and the little squares are going to be the unit tiles. Okay, so first of all, I'm going to make 3 groups, and in each group there's going to be 2 positive X tiles. So I'm going to draw those first. 1, 2. I like to do mine vertically. You can do the horizontal tiles, that's fine. And 1 unit tile. It doesn't say they're negative, so we know that they're positive. So there's 1 group, and I need to have 3 groups. So I'm going to draw 3 different groups. That's 1 group, there's 2 groups, and here's my 3rd group. Okay, so there's 3 groups. Each group represents 2 X tiles and 1 unit tile, all positive. So now let's write our algebraic expression. Okay, when you're talking about groups, groups are parentheses, right? So we're going to make a group, and what is inside the group? 2 X's and 1 positive unit tile. So that's what goes inside the parentheses, 2x, 1 positive unit tile, so that would be 2x plus 1. And because we want 3 groups, we're going to put the number of groups on the outside. So this algebraic expression reads 3 groups of 2x plus 1. So we took an expression, an algebraic expression, we drew the equivalent model using algebra tiles, and then we wrote the equivalent expression, algebraic expression. These 3 things are all equivalent ways to represent the 3 groups of 2x plus 1. Then we can show this, because when you're taking 3 groups of something, that's the same as multiplying by 3, right? So we can show this multiplication as repeated addition. We're taking the 2x plus 1 and we're adding it together 3 times. Add it together. Add the constants. 1 plus 1 plus 1 is a positive 3. Add your x's. 2x plus 2x plus 2x is 6x's. So the total is 6x plus 3. Does that match your model? Well, if I go back over here, how many total X tiles do we have? 6 X tiles. How many unit tiles are there? 3 positives, so it matches. So we took this 3 and we distributed it to each term inside the parentheses, to each term in the group, to each part of the group. Okay, the next one. Now we have 2 groups of 4 X tiles and 2 negative unit tiles. Okay, so let's model. We want 2 groups. What do we want in each group? We want 4 X tiles. So here we go. Doesn't say they're negative, so that means that they're positive. 2, 3, 4. And again, I'm doing mine vertically, but you could do horizontal X tiles. And 2 negative unit tiles. So 2 unit tiles. This time they are negative. So there's 1 group, but we want 2 groups. So we're going to draw it again. So 4 positive X tiles and 2 negative unit tiles. Now let's write our algebraic expression. it tells us that we have two groups. So that's going to go on the outside of our parentheses because groups means parentheses. Inside the parentheses is what goes in the group. Well, what did we put inside our group when we modeled it? We put 4x tiles and 2 negative unit tiles. So two groups of 4x minus 2. Let's show a repeated addition. We're repeating the groups. So we're repeating the 4x minus 2, and we're doing that 2 times. Add them together. A negative 2 and a negative 2 makes negative 4. 4x plus 4 more x's make 8x's. So we get 8x minus 4. Is that what the model is showing? Do we have 8x's, 8x tiles? Yes, we do. Do we have 4 negative unit tiles? Yes, we do. So now, do you see the pattern for using the distributive property? If you take this algebraic expression, what did we do to turn it into this total down here? What did we do to get this down here? Two groups of 4x minus 2. How did we get 8x's? Did you see that you're taking the 2 and you're multiplying it by the 4? 2 times 4 is 8x's. Then how did we get the negative 4? Can you see that we took the 2 and we multiplied it with the negative 2? A positive times a negative is a negative, and 2 times 2 is 4. 8x minus 4. Let's come back over here to the first one. See if that works. If we take the 3 and we multiply it with the 2x's, does that give us 6x's? Yes, it does. If we take the 3 and we multiply it times this positive 1, does that give us a positive 3? Yes, it does. That's the distributive property. We're distributing the 3 to each term inside the parentheses. Remember, we already learned about terms, right? We're taking the 2 and we're distributing it to each term inside the parentheses. So the distributive property allows us to take a factor and distribute it to each member or term of the group terms that are being added or subtracted. One thing we need to remember is factors. Factors are numbers that are multiplied together. Okay, so to distribute, all we have to do is rewrite the multiplication. Okay, so if we have negative 2 groups of x plus 5, then we're distributing the negative 2 to each term inside the parentheses, and distribute means to multiply. So it goes into negative 2 times x, because that's the first term. Plus is the operation. The second term is a 5. Negative 2 times 5. Negative 2 times x is negative 2x plus negative 2 times 5 is negative 10. That's the distributive property. Okay, that's rewriting it. So let's do the same thing for this example. We're going to distribute the 9 to the 4x. That means we're going to do 9 times 4x's. Then we have a plus sign that we bring down. The second term is the 6. We have to distribute the 9 to the 6. 9 times 6. Multiply. 9 times 4x gives us 36x's plus 9 times 6 is 54. Can we add together the 36x's and the 54? No, we've already learned that they are not like terms. You can only add x's with other x's. Since the 54 does not have an x, you cannot add them together. But that's the distributive property. You're just distributing with multiplication the number of groups, 9, times each term inside the parentheses. Remember, we talked about this too. We said if we have a number outside of parentheses with no operation symbol in between, that means to multiply, doesn't it? That's what we have here. We have a number next to parentheses. That means to multiply. Okay, let's do these examples. Okay, you can rewrite them with multiplication like we just did, or you can skip that step. Hopefully, you'll be able to skip that step. And what we're going to do to help us skip that step is to draw an arrow line from the 2 or from the number that we're distributing to each term inside the parentheses. So we'll start with the 2. The first term is the c. So we're going to distribute the 2 to the c. How many c's is that? 1c. So what is 2 times 1c? It gives you 2 c's. Then we're going to bring down the minus sign. And now we're going to distribute the 2 to the second term, which is the 4. 2 times 4 is 8. Cannot combine the c's with the 8, so our simplified expression after distributing is 2c minus 8. Next one, same thing. What number are we distributing? The 3. The first term is a negative 5. What is 3 times negative 5? Negative 15. Then we're going to take this plus sign, we're going to bring it down, and now we're going to distribute the 3 to the second term, which is a y. How many y's? 1 y. So 3 times 1 y gives us 3 y's. The distributive property, using the distributive property, gets rid of the parentheses. Instead of knowing how many groups you have, you're going to find out how many total constants, how many total variables you have. Okay, the next one, this one's a little bit different, isn't it? There is no number on the outside. There's just a negative sign. And what does a negative mean? It means the opposite. So we're going to take the opposite of each term inside the parentheses. The first term is a positive 7g. That opposite is a negative. So this will be a negative 7g. Then we have our minus, so we can bring that down. And then we want to take the opposite of this 3. Well, it's a positive 3. What's the opposite of a positive 3? A negative 3. And what do you notice? Do you see the double negatives here? The double negatives turns into a positive, right? So simplify it further, negative 7g and positive 3. Okay, last example. Sometimes you might see the number you have to distribute behind the parentheses. Instead of it being in the front, like you have in these two examples up here, it's behind it. Sometimes it might show, times 3. Sometimes it might not. It might just have the 3. You still need to distribute to each term inside the parentheses. So I'm going to distribute this 3 to the first term, which is a 2. 3 times 2 is 6. And I'm going to bring down the plus sign. And now I'm going to distribute it to this next term, the 6m. 3 times 6m's gives you 18m's. 18m plus 6. All right, good job, Bobcats. That's the distributive property.